Okay, now let's look at part B. Part 2. In part 2, we want to find the rate of change, but this time round we want to find the rate of change of the circular surface area of the orange cup. So basically what we want to find is the area A, okay, how this area, this circular area here is actually changing with respect to time. Alright, so actually to put it in differentiation terms, okay, part 2, okay, I'll redrawn the diagram here. What they want you to find is actually what is dA over dt. Okay, so we want to find this given, okay, some of the prior information we know from the question. We know that dV over dt is equals to 10 cm cubed per second. And we've earlier also found that, okay, the radius r can be expressed, okay, this is h, this is the radius r. The radius r can be expressed as h over 3. Alright, this was from part A. So we want to find dA over dt. So, well, one way, okay, using what we know of connected rates of change, we can find dA over dt by taking, alright, dA over, okay, dH times dH over dt. Now, why do we want to do that? Because you realize that dH over dt, right, we have earlier actually found in part 1 already. Then all we need to do to find dA over dt is just to find dA over dH. So to find dA over dH, alright, all I need to do is just to look at the area A here. Now we know that area A, okay, this is just the area of the circle, and you should recall area of the circle is pi r squared. But we want dA over dH, means that we want to differentiate A with respect to H. But I have a R here, so I need to change this R to be in terms of H, and that is where we make use of what we found in part A. Okay, I can replace this R here, okay, with what we found in part A, whereby R, I can replace it as H over 3 squared. And you will get pi over 9h squared. Okay, and once you get this, you can then take the differential of dA with respect to this is not dt, but dH, which is just equals to, okay, I move the 2 in front, so I have 2 pi over 9h. Okay, and once I have this, then I can work out dA over dt is just equals to dA over dH, which is 2 pi h over 9 times, okay, dH over dt, which we earlier found out is 5 over 2 pi. So we have 5 over 2 pi. Okay, then work it out. 2 pi can cancel, so it leaves us with 5 over 9h. And to work out a value, we need to find out what this value of h is. Okay, earlier we know that when v is equals to 8 pi, h is actually equals to 6. So we can actually put this value of, okay, over here, h is actually equals to 6. This was actually from part 1. So if we put the value of 6 inside, okay, we get 5 over 9 times 6. Okay, work this out. You actually end up with 10 over 3, and this is rate of change of area with respect to time. So the units will be cm square per second. And this will be the answer that you're looking for. So this is telling you that at h is equals to 6, or when the volume is equals to 8 pi as given in the question, the rate at which the circular area of the cone is changing is 10 over 3 cm square per second. Okay, so I hope the 3 examples here, okay, give you an idea of how we, okay, use some information to find the rates of change of different variables. And if you are done here, you can go on now to try the exercises in your textbook as reflected in your homework questions.